So now let's use this on a couple of problems back to back here. All right. So example 3, apply the intermediate value theorem, if possible, on 0 to 5 so that f of c is equal to 1. So there needs to be a 1 for a y value in between x's of 0 and 5. Okay, so let's do that. All right, now, so let's see. Number 1, we got a little checklist here. All right, so number 1 is going to be, is the function continuous? All right, so let's do that first. All right, so number 1 is f of x is continuous. It's x squared plus x minus 1. It's continuous everywhere. So f of x is continuous not only from 0 to 5, but everywhere for all real numbers or whatever. All right, so yeah. All right, so that'll be fine. And then, so that's number 1. Okay, number 2. All right, so next we need to say the y values. All right, so of the endpoints. So f, there we go. F of 0, okay, is equal to negative 1, and f of 5 is equal to, what we got? 25 plus 5 minus 1. So what's that? 29 is 29. All right. And due to that means that f of 0 is not equal to f of 5. All right. Then number 3. Okay. So since 1 is in between the two endpoint y values of negative 1 and 29, then the intermediate value theorem applies. So then by the intermediate value theorem, there exists a value c such that hold on, I got it. Such that f of c, I do it every time. I guess I'm just going to type x every time, equals 1 on the interval of 0 to 5. There you go. Okay. Now, so that's good. Now, so the next thing then is let's try this on another one. We had showing that it has a 0. So really, this time all I need to do is show that you got a. It's the same thing. It's just this time instead of trying to find 1, we're trying to find 0. Okay. So we just need to make sure that 0 is in between the two y values. All right. So this time I think I'll write it. All right. So we've got that. That a little good right there. So number 1. Okay, so again, f of x is continuous for all real numbers. So f of x is continuous for all real numbers. All right, number 2. Here we go. So f of 0 is equal to negative 1, and f of 1 is equal to what? 3 minus 1, 2 is equal to 2. Oh, that's good. All right, with again, f of 0, and this is the reason I wanted to write it this time, is not equal to f of 1. All right, we had to have them not the same. They're not the same. One of them is negative 1, the other's 2. And the good news is 0 occurs in between those two. So here we go. All right, so then by the intermediate value theorem, there exists a value c such that f of c is equal to 0. Now, it could be more than 1, but we know there's at least 1 on the interval 0 to 1. Okay, so in other words, if the beginning of the interval had a negative y value and the end of the interval had a positive y value, and it's continuous, which is what this is supposed to say. Oh, Lord of mercy. On that interval, then you're going to have a 0.